All right, hi everyone. So today we're going to continue our study on the chapter of heat. Okay, and as you can see here, we are going to uh, go into the next subtopic. So the first subtopic that we learned was about thermal equilibrium. Okay, so remember very key words, important words like thermal contact, net flow of heat is zero. Okay, and then of course it finally reaches thermal equilibrium. And one of the biggest applications of thermal equilibrium is the thermometer. Okay, and we learned how the thermometer works, what is the characteristics of good thermometer, uh, not the digital thermometer, the manual one, the one that inside still got mercury, and some thermometers use alcohol. Okay, and then of course the last thing that we learned was how to calibrate the thermometer. Okay, I hope you guys watched the video that I gave and actually if you want you can do your own sort of like homemade thermometer lah. Okay, based on the videos. But today we're going to be continuing our study talking about this concept which is called specific heat capacity. But before we talk about specific heat capacity, before we talk about specific heat capacity, we need to talk about what it means, what the word heat capacity means first. That's the more important thing that we need to understand. Once we understand what the meaning of the word heat capacity, okay, heat capacity, then we can talk about what it means, what does specific heat capacity mean. Okay, so we are going to, these latecomers, I tell you. Okay, so uh, just to inform, well, sort of inform you all lah. Okay, so we're going to be talking about heat. Oh dear. Okay, capacity. Okay, so capacity dalam bahasa Melayu is muatan. Okay, so heat capacity is muatan haba. Okay, it means how much heat can be stored lah. Okay, berapa banyak haba yang boleh dimuatkan. Okay, so that's what we're going to talk about today. Okay, heat capacity, and then lepas itu specific heat capacity, muatan haba tentu. Okay, how much heat that can be stored in a specific mass lah. Okay, which we will come to in a while. So get used to these words, heat capacity, because today and Tuesday we're going to be talking about these two subtopics: heat capacity, muatan haba. All right. So let's look at this example lah. Okay, and I want to thank Teacher Hee. Teacher Hee created this sort of like PowerPoint animation. Okay, so I'm just like copying her work. Okay, so you have these two kids over here. Okay, and one is standing in the sea and one is standing on the sand. Now, if you have ever any experience going to the beach, this would be a very common situation. You'll find that the sea is cold and the sand is hot. Okay, and the okay, so so the question that we need to ask is that why is it that in the daytime, okay, the sea is cold, the sand is hot, but both are actually under the same sun? It doesn't make sense, right? I mean, if you're all being heated at the same time, okay, by the same sun, you should be equally hot. But the reason is, why is the sea cold and then the sand pull up? We feel that it is hot. Okay, so the sun heats up the sand and the seawater at the same period of time. Logically, logically, the sun and the sea, the sand and the sea should be the same hot, right? Because they are both heated by the same sun. Okay, but we find out that actually the sand gets hot quickly, more quickly than the seawater. We're not saying that the sea is not hot at all. It is just that in comparison, the sand becomes hot faster. Okay, the sand becomes hot faster than the sea. Okay, pasir lebih cepat panas lah daripada air laut. Okay, so this is because on the heat capacity lah, we find out that the heat capacity of sand is lower than the seawater. Okay, it means dia punya muatan haba sangat kecil. Okay, berbanding dengan seawater. This is a very important concept for us to understand because heat capacity is what makes the temperature rise. Okay, so in order for you to rise, kalau kamu mau dia punya suhu untuk meningkat, okay, you must fill in let's say you have a box, you must fill in the box with enough heat, then the temperature will rise. So we find that in the case of the sand's heat capacity is much smaller. So, the kotak for sand is much smaller. Kalau isi sedikit haba, terus dia menjadi panas. Manakala sea, air laut, the heat capacity is much bigger. You need more heat, then the temperature can rise. And that's exactly what the heat capacity means. How much heat do you need? Oh dear, I'm getting a cold. How much heat you need in order to raise the temperature? Okay, that's what heat capacity refers to. So we find a different object, sorry for the spelling, different object have different heat capacity. Okay, line object have different heat capacity, which is why although the sea and the sand, mereka dua-dua dipanaskan oleh matahari yang sama, we find that the sand becomes hotter faster. Okay, the sand punya temperature rises faster compared to the sea. Okay, and this is because the sand's heat capacity is much lower. It is so much easier to make the sand become hot, okay, than the sea to become hot. Of course, the sea will become hot after a while, okay, but we find that the sand becomes hot faster because the heat capacity is lower. Okay, so in definition, by definition, the heat capacity of an object is the amount of heat that is required to increase the temperature of the object by 1 degree Celsius or 1 Kelvin. Okay, we spoke about Kelvin in the previous subtopic. It is a different measurement of temperature. Okay, of course there is a way to convert between Celsius and Kelvin, which we will come to in the fourth subtopic. Okay, but heat capacity is how much heat you need in order to increase the temperature of an object by 1 degree Celsius. Means kalau mau kasih naik 1 degree kan, you need a certain amount of heat, then the temperature rises. When temperature rises, then we will feel hotter. Okay, so in the case of the sand and the sea, we find that because the sand becomes hotter faster, okay, the heat capacity of the sand is much lower. You just need a little bit of heat, then the temperature will rise. Manakala the sea, okay, it is not that the temperature is not rising, it is rising. It just rises slower. Okay, so the temperature of the sea rises slower because the heat capacity is much bigger. You need more heat in order for the temperature to rise. Okay, very important concepts for us to understand. Now, so the heat capacity depends on two things. Number one, it depends on the mass of the object. Okay, how much mass it is. And number two, it depends on the type of material. Okay, so let's talk about the first one first. This is a general formula. C equals to the amount of heat over the difference in temperature. In a while, we'll come to this. Okay, Q is the quantity of heat supplied, and then delta theta. Okay, delta theta is the change in temperature. Okay, the unit for heat capacity is joules per degree Celsius. This is how we read this, joules per degree Celsius. Last time in the old books, they used to write, they don't write this one, they write joules per degree Celsius. Okay, or joules per Kelvin, depending on what unit you use for the temperature. Okay, but nowadays we try to standardize everything. We don't use the per anymore, so we use -1. Okay, but it still means the same thing. Okay, because up here is joule, bahkan di bawah is degree Celsius. So joules per degree Celsius. And that's the unit for heat capacity. So let's take a look at these two pots. Okay, so these two pots are the same size. Well, they're roughly about the same size. Okay, so these two pots are the same size and they are both containing hot soup. Okay, so, and as I said just now, the heat capacity of an object depends on the mass of the object. Okay, so we find that there's a different, when the mass is different, the heat capacity is different. We find that the soup in pot A remains hotter for a longer time, okay, than the soup in pot B. Okay, and this is because the heat capacity of the soup in pot A is much higher. The bigger the mass of an object, okay, then we find that the heat capacity is more. Of course, because there's more heat in there. So it can remain hotter longer. Okay, so very important things for us to remember. When heat capacity is big, okay, it becomes hotter much longer, but it also takes a long time to become hotter. Okay, so this is a very important thing that we need to grasp and know the difference. Okay, when something is much bigger, okay, it takes a longer time to become hotter, but it also takes a longer time to become cooler. More menyejuk bahkan, because I mean, if you think about this, memang, if you leave the soup out there, lama kelamaan dia akan menjadi sejuk. But the question that we need to ask is, which one becomes colder faster? Obviously, is the soup with the pot with the less soup lah. Okay, and that is because this one takes a long time for the suhu to turun because the heat capacity is more. So when you think about heat capacity, try to avoid thinking about get hotter or get cooler lah. Okay, best to think about whether the temperature increase faster or the temperature increase slower, or temperature decrease faster or temperature decrease slower. Okay, so in this case, we find that this soup, this pot A, okay, so pot A punya soup, okay, it takes a longer time to cool down. Okay, that's why we say soup in pot A is hotter lah. Okay, because there is more mass. If there's more soup, there's more mass, it's going to take a longer time for the suhu to turun. This one will take a faster time to cool down. It will take a faster time for the temperature to decrease because the heat capacity is very small. Okay, and this is a very important conclusion. If the heat capacity is big, okay, kalau heat capacity-nya besar, contohnya macam ni, okay, it takes a longer time to become hotter and it takes a longer time to become slower. Okay, precisely because you need more heat to increase or decrease the temperature. Okay, in the opposite side, on the right side, okay, the soup with the less mass, if the mass is smaller, it takes a faster time to become hotter and a faster time to become colder. Okay, lebih cepat meningkat suhu dan lebih cepat mengurang suhu. Okay, because the heat capacity of a mass that is smaller, okay, is smaller. Okay, so this is a very important distinction that we need to make. Okay, the bigger you are, the better it is that you store heat. Okay, so it takes you a very long time to become hot, but it takes you a very long time to become cooler as well. All right, next point. Okay, so the first factor that affects heat capacity is the mass of the object. Okay, so just now we talked about two different methods. Now we're going to be talking about different type of object, and this is everybody knows this. No need to study physics also, you know. Okay, you know what's going to happen, but because we are physicists, so we have to study why. We have to know why this is so. What is the scientific explanation behind this? Tidak cukup untuk kita mengetahui bahawa inilah hakikatnya macam tu. Okay, we need to know why. We need to explain why it is that when you heat up the iron rod and the wood, this is besi and this is kayu. Okay, when you heat it up at the same time, and assuming that the kayu doesn't burn up lah, okay, kita kasi panas saja tapi dia tidak terbakar. Okay, we find that because the iron and the wood have the same mass, okay, we find that the iron rod will get hotter faster than the wood. Okay, because this is very normal. Okay, selepas 2 minit if you pegang the iron rod and you pegang the kayu, obviously the iron rod will be much more hotter. Okay, now in terms of heat capacity, let's think about this. In terms of heat capacity, which one has the bigger heat capacity? Okay, obviously it is the wood lah, because the wood takes a longer time to become fast. The wood takes a longer time to become hotter. So because of that, the heat capacity of wood is much bigger than the heat capacity of iron. Okay, let's say we take out the fire lah. Katakan saya kasih keluar itu api and I allow the hot iron rod and the hot wood to cool down. Okay, so I allow the two of them to cool down. Which one will cool down faster? Again, the same answer. The iron rod will cool down faster. After 2 minutes, you hold the iron rod and you hold the wood, then you realize that, oh, the iron rod macam mau sejuk sudah. Okay, but the wood is still very hot. Okay, and this is because the iron rod heat capacity is lower. Okay, lower means heat capacity lower means faster become hot, faster become cool. Okay, so you know, and that's a very important thing that we need to remember. Okay, sorry, we try not to say faster become hot, faster become cool. Sorry, faster increase temperature, faster decrease temperature. Okay, that's the actual this one. Okay, and the basic concept is the heat capacity. Okay, so next time if you are asked to explain why is it that metal heats up faster than wood, don't just say, oh, sebab itu adalah lumrah alam. Okay, please don't say that. Okay, explain it in terms of the heat capacity. Okay, heat capacity of heat capacity of iron is smaller than the heat capacity of wood. So because the heat capacity is lower, it will increase temperature faster or decrease temperature faster. Okay, depending on which situation you want. Okay, so, oh, sorry. So we find that the heat capacity of the iron rod is lower than the heat capacity of wood, which explains why it becomes hotter faster. All right. So this is an example of a calculation which I think is found in your textbook. So if you have 2000 joules of heat that is supplied to both object A and B, we find that object A experiences a rise in temperature of 1 degree Celsius and object B is 2 degrees Celsius. Now, from this one sentence, can you tell me, I mean, try to think which one has the bigger heat capacity? Okay, mana satu yang mempunyai bigger heat capacity. So when we calculate this, we find that for object A, because it is 2000 joules over 1 degree Celsius, we find that the specific capacity is 2000 joules per degree Celsius. Okay, it means in order for you to rise 1 degree Celsius, you need 2000 joules. Manakala, for object B, when we calculate it, we find that, oh, okay, it is 2000 divided by 2 degrees Celsius. You only need 1000 joules to increase by 1 degree Celsius. So obviously, A has the bigger heat capacity. Okay, because in the same amount of time, A rise temperature 1 degree Celsius saja. So it takes the increase in temperature is smaller. Okay, so obviously the heat capacity is much bigger. Okay, just remember, if the increase in temperature is small, okay, sikit saja dia punya suhu naikkan, means the heat capacity is bigger. Okay, for example, wood. Okay, if the increase in temperature is very if the increase in temperature is very big, okay, means that the heat capacity is small. Okay, because dia cepat saja naik. Okay, but in the same amount of time. So we find that object A has a higher heat capacity because the increase in temperature in A is less than B. Okay, please take some time to let this sink. Okay, increase in temperature. If the increase in temperature is less, then the heat capacity is much bigger. Okay, because dia perlu lebih banyak haba untuk meningkatkan suhu. It means you need to supply more heat in order for you to increase the temperature. Okay, so yeah. So that's the first part, which is the heat capacity. Okay, do you guys have any questions? Anything that you want me to repeat? Because after this, we're going to go into a slightly different one, which is specific heat capacity. But I need you to understand this concept of heat capacity. Dalam bahasa Melayu, it's called muatan haba. It's how much heat you can put in, then it will increase 1 degree Celsius. Okay, so we find that iron needs very little. A little bit of heat increase temperature. Okay, so and the relationship is very important. Okay, the bigger the increase in temperature, okay, then the smaller the heat capacity, because a little bit of heat terus naik sudah suhu. Okay, right. So if there's no questions, let's continue. So Next is specific heat capacity. And this is the definition of specific capacity. We find that it's almost the same as heat capacity, except that because of the word specific, we have to add in the word 1 kg. Okay, so I want to point out that there are 4 things that must be mentioned when you talk about the definition of specific heat capacity. The first one is the quantity of heat. Okay, specific heat capacity is the quantity of heat required to raise the temperature, okay, which is the second keyword, okay, of 1 kilogram of material, oh dear, okay, by 1 degree Celsius or 1 Kelvin. Okay, so how much heat you need to raise the temperature by 1 degree Celsius, okay, for 1 kilogram of object. That's why it's called specific. Okay, because now we are putting the constant variable as the mass. Okay, so let's say you have 2 objects with the same mass. Okay, 1 kilogram of iron and 1 kilogram of wood. Okay, then we talk about specific capacity. If it is heat capacity, if you take a look before, okay, heat capacity is almost the same. Okay, if you take a look, heat capacity object is the amount of heat required, okay, first thing, and to increase the temperature of the object, and then by 1 degrees or 1 Kelvin. Okay, so the only difference between the definition for heat capacity and specific heat capacity is that one word, 1 kilogram of material. Okay, but in other words, the definition remains the same. Amount of heat to increase temperature by 1 degree Celsius or 1 Kelvin. Okay, but in the case of specific heat capacity, we want to talk about 1 kilogram, very specific 1 kilogram, because as I said before, the mass of the object actually affects the heat capacity. Okay, for example, if you have 1 kilogram of iron and half a kilogram of iron, same material, okay, but because the mass is different, the heat capacity is different. Okay, because half a kilogram of iron will get hotter even faster than the 1 kilogram of iron. Sebab dia punya jisim berbeza. Okay, so which is why when we talk about specific capacity, we have to really specify how much mass, okay, are we comparing all the materials to. Yeah, let me get back to this. Okay, so we specify the words 1 kilogram of material. Okay, in terms of the formula is Q, which is the amount of heat. Okay, Q refers to the heat energy, whether it is absorbed or released. Okay, so heat energy is equals to the mass of an object times the specific heat capacity times the difference in temperature. Okay, kalau kita ikut yang formula tadi kan, it should be Q equals to MC delta theta, because delta theta is the difference in temperature. Okay, so if you want to know how much heat is supplied, okay, to increase the temperature of a certain material, you just need to know how much mass there is and the difference in temperature. Okay, because specific heat capacity is a constant. Different materials have different specific heat capacity, okay, which you don't have to remember. Okay, usually specific capacity will be given to you kalau soalan calculation lah. Okay, but we need to understand what those numbers mean. Okay, so if we take a look at this comparison, if your C is small, okay, if the value of your C is specific capacity, ini symbol untuk specific capacity guys. Okay, so specific capacity, the symbol is small c. Oh dear, small c. So if your value of the C is small, okay, this is what it means. It will become hotter faster, it will become cooler faster, and the increase in temperature will be higher. Increase or decrease lah. Okay. Yeah. Sebab dia punya suhu akan meningkat dengan cepat. Okay, so you will have a higher increase in temperature. Manakala on the opposite side, if your C is very big, okay, so it will become hotter slower, it will become cooler even slower, okay, and then it will have a lower increase in temperature. Dia punya peningkatan suhu kan sangat perlahan. So in the case of the sand and the sea just now, okay, the first picture that we saw, the sand and the sea, right, which one has the smaller sea and which one has the bigger sea? Sorry, bigger specific capacity. Okay, we find that in the case of the sand and the sea, the sand, sorry, the sand, yeah, the sand, okay, has a smaller specific capacity. Manakala the seawater, okay, the seawater has a higher specific heat capacity because it takes a very long time to become hotter, and it also takes a very long time to become cooler. Okay, which is why, for example, if you ever go to the sea at night, right? If you go to the sea at night, you'll find out that, oh, okay, why is the seawater so warm? Okay, because you know the whole day the seawater dikasih panas, 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 kan. Then when the sun set and the weather becomes a little bit cooler, because the sea, the specific capacity of the seawater is so big, okay, it takes a very long time to become cool. Okay, so if you, let's say you go at about 10 p.m. You find that, kenapa ni the sea water macam panas-panas lah, you know, like masuk sauna like that. You know, like, wow, syoknya mandi air panas-panas. Because the whole day sudah kena kasih panas oleh matahari. So when night time comes, it takes a longer time to become cooler. Okay, manakala the sand by 10 p.m. okay, it's already cold already. It's like what? Okay, macam tidak pernah kena panas. Okay, sedangkan at 10 a.m. the sand is very hot. Okay, very hot, very fast. Tetapi kalau kau masuk di dalam air laut at 10 a.m. kan, wow, siapnya sejuk betul. Okay, because it takes a very long time for seawater to heat up. Okay, and this concept is very important because you know when people build houses, when people build bridges, you know the concept of specific heat capacity is very important to engineering. Okay, engineering, design. You know, if I had done the Newton's car design PBL with you after this chapter, then a few of you would have to change your design because some of the materials you use are like, wow, amazing. Okay, the specific capacity too low. Okay, all right. So here are some applications. Okay, here are some applications of specific capacity. Today, I'm really going to talk more about the application. On Tuesday, we will talk more about the calculation. So one very important application is, why is it that when you have a cooking pot, okay, why is it that when you have a cooking pot, the pot itself is made of metal. Tetapi the pemegang is made of an insulator or plastic. Usually it's plastic. Okay. I have seen, okay, I have seen places where they sell, the whole thing is metal. Okay, the pot is metal, the pemegang also is metal. Okay, it's obviously 2 times cheaper than this kind of pot lah. Okay, but it really doesn't make sense at all. Why would you have the pemegang? What is the function of the pemegang? Nama pun pemegang. Okay, the function of the handle is so that you can hold it, you see. So if you want to hold it, and the handle itself is made of metal, okay, and you know that the specific heat capacity of metal is actually very low, you know, compared to plastic. Okay, so we find out that the base is made of copper. Usually, the base is made of copper or certain metal because copper has a very low heat capacity. Low heat capacity means it can become hot very quickly. Okay, manakala the handle, okay, handle is made of an insulator. Insulator is penebat lah. Okay, so, and the handle is made of a material that has a high heat capacity. Okay, because high heat capacity means it will take a longer time to become hotter, which is what we want. Otherwise, when you cook your food and then you hold the handle, if the handle is made of metal, it's going to become very hot very fast, right? Then you know you will terlepas kamu punya lauk yang kau masak, and then what a waste begitu. Okay, so yeah, next time when you if you ever have a chance to go and buy a pot, right? Okay, think about this. Don't buy a pot just because of the price tau. Tetapi dia punya pemegang adalah besi. Okay, you go to any place that sells pot, and you sure you see this one. Okay, I remember seeing kuali lah especially. Okay, there are a lot of kuali the pemegang at the side, right, is also metal, and I'm like, okay, you know. I mean, it's dangerous lah. You know, what if you terpegang that this one, you forgot to, I mean, most people, they will hold a cloth and everything, right? Yeah lah, fine. Okay. Even holding the cloth itself lah, kalau kamu balut dengan, let's say you balut your tangan, okay, with the kain, and then you pegang the pemegang. Okay. So obviously the heat doesn't get transferred to you because, you know, the specific heat capacity of the cloth is high. So it takes the cloth a very long time for it to become hotter. Okay, but it still doesn't make sense lah. You know, why would you just buy it because it's cheaper? Okay, get a handle that is made of plastic or, you know, of some insulator lah, so that the specific heat capacity is high. It doesn't become hotter easily. Okay, so it's a poor conductor of heat. Okay, now other applications are, we want a transparent pot cover so that you can see the food, so that you can see the food while it is being cooked lah. And the food cover will trap the heat. Okay, so you don't have to supply so much heat lah. Okay, this is good, especially if you're cooking like soups, you know, or stews, you know. So you, or if let's say you fry veggie. Sorry, I don't know how many of you like cook your own food lah. But if you like cooking as much as I do, okay, you will realize that this is a very important thing lah. Okay, after you fry your veggie, after a while, then you cook, then you cover it while, you know, supplying the heat, but you lower the api, okay, because the heat inside, okay, will actually trap. Sorry, okay, the heat inside will actually trap the. The cover will actually trap the heat, so the heat will cook the inside. So yeah, so whenever you cover the food, okay, while you're still cooking it, kasih turun dia punya api lah. Okay, nobody covers the thing, and then make the fire even bigger. You know, it's like, okay, like boom. Okay, tolong jangan. So you know, when you cover the food, you lower the sound because you want to save money lah. You know, you don't want to spend too much heat. So you allow the heat yang diperangkap ini untuk memasak itu makanan sendiri. Okay, talking about all this cooking, it became me hungry. Okay, one last one is, we find that the base has a high density so that, you know, the pot is more stable lah. This is logical. Okay, the base must be heavy. Okay, kalau kamu punya cover yang heavy, then something is wrong. Okay, kamu punya, the base of your kuali should be heavier, or in other terms, we say it's high density lah. Okay, bila dia lebih tumpat, okay, then it will be more stable and it won't easily topple, which is good for your food. Otherwise, if your pot boleh topple dengan senang-senang kan, kesian kau punya makanan sentiasa dibazirkan. Okay, so this is one example. So wood has a specific heat capacity of 1,700 joules per kilogram per degree Celsius. So first thing, this is the unit for specific heat capacity. Remember, heat capacity just now is just joules per degree Celsius. This is heat capacity. Okay, but because in specific heat capacity, we add the element of 1 kg. So the unit for specific heat capacity is joules per kilogram per degree Celsius. Okay, because if you remember the formula, C equals to Q over M delta theta. Okay, so joules per kilogram per darjah Celsius, per degree Celsius. Okay, so it's almost the same as heat capacity, except that you add the per kilogram. Okay, now in your entire study of physics, this is the one quantity that probably has the longest unit. Yeah, as far as I know lah. Okay, as far as I can remember, okay, this unit is one of the longest. Okay, yeah, payah sikit mau ingat lah, joules per kilogram per degree Celsius. Okay, but of course try to remember this lah. Now, what does this 1,700 joules mean? Okay, very important for us to understand. So 1,700 joules per kilogram per degree Celsius means that for 1 kg of wood, okay, you need 1,700 joules of heat energy so that dia punya temperature can rise by 1 degree Celsius. Okay, very important. If you have 1 kilogram of wood, okay, you need 1,700 joules of heat energy to increase the temperature by 1 degree Celsius. Okay, and that's what these numbers mean. Okay, and different materials have different specific capacities. Look at all these examples. This is in your textbook lah. Okay, so just now, oh, there's no wood here. So for example, water lah. Water has one of the biggest specific capacities we know. That's why seawater takes a very long time. This is 4,200. You need to supply 4,200 joules of heat to 1 kg of water in order for it to increase by 1 degree Celsius. And our sea is definitely not 1 kilogram of water. Okay, it's don't know how many kilograms. Okay, so obviously you need a lot. Kalau 1 kilogram saja, kalau mau kasih naik 1 darjah Celsius, you need 4,200 joules. Imagine the entire sea. Okay, and you want to increase it by don't know how many degrees. So that's why water takes a very long time to get hot. Okay, so yeah, but actually seawater is even less than water. Yeah, it's easier to heat up seawater than water. But if you compare seawater and, for example, gold, okay, this may not be correct, but fine. So gold is 300 joules per kilogram. So it gets hot very easily. Okay, if we compare all the metals, okay, we find that lead, lead is, what is lead? Plumbum. Okay, so plumbum becomes hot very easily compared to gold. Okay, and aluminium, 900 joules per kilogram per degree Celsius. 1 kilogram of aluminium needs more heat to kasih panas berbanding dengan gold. So even among metals itself, ada yang lagi cepat menjadi panas, ada yang lagi lambat menjadi panas. But generally, metal compared to liquid, okay, metal heats up much more faster lah. Okay, because the sea is much more smaller. Okay, so another example is non-metal. Okay, non-metal is, for example, polycarbonate. Polycarbonate is plastic lah. Plastic is 1,250 joules per kilogram per degree Celsius. Okay, so that's why, whenever, like the example I gave just now, kalau cooking pot makan, okay, usually the base, we want it to be a metal. Okay, for example, iron or copper or lead. Lead no lah. Usually iron or copper lah. Okay, because the specific capacity is very small, because hotter faster. But the pemegang, okay, the handle, okay, the handle, usually we use polycarbonate, which is a kind of plastic, because it is 1,250. Okay, of course we want to use, the higher the specific heat capacity, the better lah. But obviously you cannot use water as a handle lah. Okay, come on. Okay, don't just look at the numbers. Think of the reality of the situation. Is it possible for us to have a water handle? Okay, we can't. Okay, so we be realistic. We want something that is hard, okay, keras, boleh dipegang dan boleh mengangkat, the cooking pot. Okay, but it has a high specific capacity lah. I'm not saying that it won't become hot. Okay, I say, oh, okay, wah, copper cepat panas, means polycarbonate kan dia tidak akan menjadi panas. Salah, it just becomes hotter slower. Dia lambat menjadi panas, and that's what we want. Okay, we don't want the we don't want the iron kuali to become to be as hot as the polycarbonate handle. Okay, we don't want that because we want to hold the handle and then transfer the food or whatever lah. Okay, that's why different specific heat capacities play a different role. Okay, and generally we find that gas also has a very high heat capacity, specific heat capacity. Okay, not as high as liquids lah in general. Okay, so like methane is kind of gas, it's about 2,200. Okay, so and as I said before, the value of C, ini semua nilai-nilai ini you don't have to hafal. Okay, although I would say that if you really want to hafal air lah. Air is by far the most popular material for, let's say, for example, calculation questions. So just remember 4,200. Okay, the specific capacity of water is 4,200. But daripada kamu mengingat dia punya nilai, better to remember what does the 4,200 mean. That's more important actually. Okay, 4,200 means for 1 kilogram of water, you need 4,200 joules of heat. Okay, 4,200 joules of heat is no joke. Okay, in order to increase the temperature of the water by 1 degree Celsius. Baru 1 degree Celsius, you know. Okay, what is the boiling point of water? Boiling point of water is 100. Normal temperature of water, should be about, let's say 27 lah. Okay, you want to increase 27 degrees all the way to 100 degrees. Okay, let's say 1 kilogram of water. Okay, think about this. What is the difference in the temperature here? 27 to 100 is 73 degrees Celsius. You want to increase water, when you boil water, you want to increase the temperature to 73 degrees Celsius. Kamu mau kasih naik suhu air kepada 100 darjah Celsius, you need to increase 73 degrees Celsius. Okay, and let's say you have 1 kilogram of water. 1 kilogram of water is about 1 liter. So 1 liter of water, okay, want to increase 1 degree Celsius, you need 4,200 joules of heat. Okay, 73 degrees Celsius is actually 4,200 times 73. That's a lot of heat. Okay, that's a lot of heat that you need in order to mengasih panas air. Okay, so 4,200 to us may just be another number. But when you want to heat up water, the next time kamu panaskan air untuk membuat Milo atau untuk membuat kopi atau untuk membuat teh kan, think about this. Okay, 1 degree Celsius, you are already supplying 4,200 joules of heat. Itu pun kalau air kamu adalah 1 kilogram. Okay, bayangkan 73 darjah Celsius, you want to boil the water, 4,200 times 73. Sorry. Be very dramatic and count it out for you. 4,200 times 73 is 306,600 joules. Okay, 306,600 joules of heat. Okay, that's a lot of heat. Okay, itu pun 1 kilogram air. Bayangkan kalau kau pakai, cerek yang sangat besar. Okay, imagine how much heat you're supplying. So yeah, so which is why guys don't play with fire. Okay, to play with fire is because fire is very important. Okay, 1 degree Celsius are also 4,200. Kamu mau kasih panaskan air 73 degrees Celsius, sangat banyak. Okay, so so from the table we find that water has a higher specific heat capacity. Water needs to absorb a large amount of heat in order to have a small rise in temperature. Okay, kalau berbanding dengan cooking oil or olive oil, 1850 is very little. That's why when you cook with cooking oil, okay, very fast the oil becomes hotter. Okay, if you want to do a comparison can, you put the same amount of oil and you put the same amount of water, you see which one boil first. You find that the cooking oil will boil first. Okay, because the specific capacity of cooking oil is much smaller than water. Okay. Okay, so because of this, okay, and as I said, the specific heat capacity of water is high. Okay, takes a long time to become hotter, takes a long time to become cooler, which is why water is a very good cooling agent. Okay, so whenever this cooling agent is an agent which makes the engine become cooler. Okay, so we find that water is a very good cooling agent. When you have, kalau kamu engine kamu jadi lebih sejuk kan, we find that the cooling water, okay, is actually just plain water. Okay, so in other words, materials like metal has low speed. Okay, this one I've already mentioned before. So for example, explain why we cannot use a cooling system of a refrigerator to cool the hot room. Okay, I tell you, I don't know, I have lost count of how many people have done this Toinco thing before. Okay, so they in a very hot day and then they just open the refrigerator dan bertindak sebagai aircon kono. Okay, but it's so inefficient. Okay, the cooling system of a refrigerator is very small. Okay, less cool air flow from the refrigerator flows out compared to the hot air flow in. Imagine if you open the door, okay, dengan andaian yang, okay lah, actually kan my fridge is a natural aircon. Okay, don't need to buy aircon, just open the refrigerator door. Okay, but it doesn't make sense because the cool air that keluar is so small and so tiny compared to the hot air yang masuk. Okay, and some of the position of the refrigerator is on the floor. So the cool air does not flow outward. Okay, so yeah, guys, if you've ever done this, stop doing this. Okay, please don't open your refrigerator door in order to cool the room. Okay. Now, as I mentioned just now, why is water a coolant in a car engine lah? Okay, kenapa kita guna air untuk menjadi penyejuk? Okay, coolant dalam bahasa Melayu is called penyejuk lah. So uh, we use water as a coolant agent. Okay, agent penyejuk. Okay, dia punya fungsi adalah untuk menyejukkan enjin kereta. Okay, so we find that. Okay, so in an engine, those of you who really went into the specifics of the engine in your PDL, you may know this lah. Okay, so we find that water is circulated. Let me see. Okay, so we find that when water enters the engine, okay, through a specific this one, so the heat generated from the combustion system in the cylinders, okay, will be transferred to the water, and that's the important thing because when the engine, you know, when the pistons run, bila engine itu this one, there's a lot of heat lah, ada banyak haba yang dihasilkan. So the haba yang dihasilkan, okay, haba yang dihasilkan itu, it needs somewhere to go. Okay, so the best place to go to will be in the water. Because water menjadi panas dengan lebih lambat. It can absorb a lot of heat, okay, dan tidak menjadi panas dengan cepat. Okay, and that's a very important thing. No? Okay, dia macam orang yang panjang sabarnya. Okay, macam mana kau ejek dia pun kan, okay, macam mana kau kasih olok dia lah, macam mana kau kasih hina dia kan, dia panjang sabar before dia finally meletup lah. Tapi, you know, water is like that lah. It can take in a lot of heat. Dia boleh menerima banyak haba, and it takes a very long time to become hot. Okay, which is why it's very good. So the heat is transferred, okay, into the water. The water is circulated by the water pump. All this is in your this one, and we find that we lose the heat. Sorry, the air drawn in by the radiator fan. So the radiator fan will make the water cool down. Okay, so di sini, okay, over here, the water becomes hotter, flows over here. Then when come over here, the radiator fan will make the water become cooler. Water become cooler, flow back, go here, become hotter, pump here, go here, become cooler, go here, become hotter, and so on and so forth. Okay. Of course, yeah, sometimes you get leaking water or sometimes your water leak out. So top up balik lah. Tapi you can just top up balik with, you know, normal water and it will be totally fine. Okay, but that's how it works. So the heat is lost from the cooling fins to the surroundings. So on this side of the engine here, there's cooling fins. So the radiator fan, when bila dia sedut udara masuk, udara yang masuk itu akan menyejukkan air yang sudah panas. Dan air yang sudah panas itu, it will flow back in here untuk menjadi panas semula. Okay, and that's how the coolant system works. Okay, so so characteristics are specific heat capacity of the liquid should be high so that it can absorb and release more heat with a small change in temperature. The freezing point of the liquid should be low so that it's not easy to freeze. Okay, boiling point of the liquid should be high so that it doesn't evaporate easily. It is very important. If your 100 degrees is very high, okay, so you know if let's say you don't use water, you use a liquid that has a lower boiling point, which is not good you know, because then bila cecair itu sudah menjadi panas kan, then dia mendidih. Okay, boil inside the car engine, it's not good sign for your engine. Okay, which is why we generally use water because the boiling point of the liquid is high. The car engine doesn't go up to 100 degrees Celsius or even if it does, it doesn't heat up the water until 100 degrees Celsius. Okay, so it's good enough. We need more liquid. Volume of the liquid should be high so that you can prevent overheating. And then in this case, you want the rusting rate, kadar pengaratan. Okay, the rusting rate of the metal should be low so that it doesn't rust easily. Okay, because we're using a lot of water, okay, we're using water in the engine, so we want all the metals here kan untuk tidak berkarat dengan cepat. Okay, we don't want it to be kena sedikit air terus berkarat. Okay, then there's no point. Okay, so that it will last a little bit longer. Okay, Another example of an application is sea breeze and land breeze, bayu laut dan bayu darat. Okay, so we find that sea breeze happens during the day and land breeze happens during the night. So the breeze is what makes us feel cooler. Okay, so we find that land has a lowest, sorry, yes, land. Okay, sorry, the sand is here, right? Okay, so land has a lower specific heat capacity, so it becomes fast. It becomes hotter faster, lah. Okay, it becomes hotter faster. So because of that, the hot air will rise up over here. Okay, dan ini berlaku dalam perolakan. Okay, which is this is you study this in geography and also maybe in science form 3 lah. I'm not really sure. Okay, but the idea of sea breeze and land breeze also comes from this specific capacity. Land become in the daytime, the land becomes hotter faster. So the hot air will rise up. Okay, bila air pula. When the hot air rises up, then we find that oh no air over here. So the cool air will blow from the sea to the land. Okay, because hot air always rises. Okay, udara panas sentiasa naik. So when hot air rises up, okay, then we need the air to replace lah. So the cold air will blow in from here. So we call this breeze the sea breeze. Okay. In opposition, at night, we find that in the sea, okay, it is hotter. Okay, so because the whole day sudah kena kasih panas makan, and at night, the sea takes a very long time to become cooler. And since the sea takes a long time to become cooler, there is more hot air over here. So the hot air over here rises up, and when the hot air over here rises up, the cold air will blow from the land to the sea. Okay, and we call this the land breeze because it is the breeze that comes from the land. Okay, this is the sea breeze because it is the breeze that comes from the sea. Okay, but in both cases, it is the same. Hot air must rise up. So the question that you must ask is, di mana dia lebih panas? Where it is hotter, that's where the hot air will rise. And then when the hot air will rise, cold air must come in to replace the hot air. And then of course, yes, I know. The cold air, when it goes in, then the cold air will become hot because on the land. Then the hot air will rise up. And then more cold air will come in. And then the hot air will rise up. And then more cold air will come in. And then the cold air will become hotter. And then the hot air will rise up. Dan seterusnya, dan seterusnya, dan seterusnya. Okay, that's how sea breeze and land breeze happens. The only thing you need to know is, where is it hotter? Okay, in the daytime, it is hotter in the land. At the night time, it is hotter in the sea. So where it is hotter, the hot air will rise up. When hot air rises up, cold air will come in. Okay, that's just the natural flow of air. Okay, so yeah. But actually, if you think about it, I know in geography you learn this as a cycle. When the hot air rises up, bila udara panas naik, bahkan dia makin lama makin sejuk. Okay, so when dia makin lama makin sejuk, bahkan then dia akan terturun ke bawah semula. Okay, yeah, that's normal lah. Okay, but in terms of physics, we only want to talk about this in terms of why the hot air rises up and why the cold air masuk. Okay, in geography, you learn that this is a cycle. Okay, hot air rise up, then dia menjadi sejuk, and then dia turun, and then dia sendiri akan mengganti diri sendiri. Okay, so it's like sistem penggantian. All right, more example. I think I have one or two more. Yeah, last two. Okay, so for example, in when you build a house, when you build a house, you also have to take into fact. You have to also take into consideration specific capacity, because we have to talk about the design to improve the ventilation of the house and to ensure the temperature inside the house is not too high. Okay, so example, we use a clay roof lah. Okay, clay roof. Clay is tanah liat. Okay, because clay has a high specific heat capacity. So high specific heat capacity can absorb and release more heat. Okay, it takes a long time for clay to become hotter. Okay, so because of that, it can absorb more heat. Okay, a very common one that we see, okay, is zinc roof lah. Okay, atap zinc. Okay, so kalau atap zinc kan, the problem with zinc is that it has a low specific capacity. Low specific capacity is not good because dia akan menjadi panas dengan lebih cepat. Okay, dia tidak mampu untuk menyerap haba, okay, yang banyak. So the haba will go into the house. So although zinc is cheap, okay, zinc dia tahan, it is cheap, okay, but the problem is it makes your house become much hotter. Okay, we don't want that because kamu tinggal di dalam rumah kan, so you don't want to have a zinc roof because it makes your house become hotter. Okay, unless you want to spend money to pasang aircon yang banyak-banyak. Okay, better to spend the money in investing in a better roof, like clay roof. Okay, yeah. Now most houses their roofs are made of clay lah. Okay, especially yang ada kena buat ni kan. I know macam rumah kampung kan memang banyak yang digunakan, memang banyak pakai atap zinc because zinc is cheap. Okay, no doubt zinc is cheap, but the problem is it makes your house become hotter. Okay, kalau yang rumah tradisi yang sangat lama tu kan, yang diorang menggunakan daun. Okay, daun kering. Actually, leaves have a very high specific heat capacity, and it does make the house a lot cooler. But the problem with leaves is kalau hujan lah. Okay, kalau hujan then you have a big problem over there. Okay, so this is the part that involves specific heat capacity. The others are just very normal. Okay, you want to have more windows. The more windows your house has, then it allows more air to flow in. Okay, allows more air to flow in and flow out. Okay, but this is also another thing that I constantly see lah. But this is a personal. Ini sebab dari kecil kan saya diajar beginilah. So in my house last time, my mother, she will always open the window and like, die, so want to open window. But my neighbor, which neighbor? I have one neighbor lah. I have a few neighbors kan. Dari pagi sampai malam kan, the windows and the doors are always closed. And that time, aircon is not a very big thing lah. So tiada aircon. So I'm like, how do people survive in a house where the windows and the doors are always closed? It's like diorang tidak rasa panas kan di dalam. I feel like it's so suffocating. But yeah, so until today, I cannot know. Like if let's say if I don't turn on my aircon, yes, obviously if you turn on your aircon, you need to close the windows down. But let's say you have no aircon, or you don't turn on your aircon, and then you close your window and the door. So there's no air that is going in, and there is no air that's going out. No, sorry. There is lah. Okay, memang ada celah-celah kan. So adalah udara masuk dan adalah udara keluar. Tapi sangat sikit tau. It's so little. So it's like, how do people survive in those conditions? I would feel very suffocating. Okay, not to mention even more hot. Okay, but some people like it that way. I still don't understand why. Okay, some people like it that way. I feel like, oh, it's very hot. So if like for me, if I don't turn on the aircon gun, I must open the windows. I must open the window. It's like a disease for me already. If I don't open the window, I feel like okay. Okay, some other houses, they have pasang ventilation fan. So the ventilation fan, in the kitchen, you have the ventilation fan. Okay, but the purpose of the ventilation fan is to actually suck out all the smoke so that your whole house doesn't smell like nasi lemak. Okay, so or ikan masin. So the function of the ventilation fan is that. But sometimes, especially some houses, you find that the ventilation fan gun, I wonder if I can draw it. So let's say the roof over here, right? So the ventilation fan, so there's like this big orb over here. Then this one akan berpusing. But the point is, dia berpusing untuk menghisap udara panas keluar. Okay, and untuk membenarkan udara sejuk masuk. So we call this ventilation fan. Is to suck out the hot air from inside the house. Okay, so when hot air is sucked out, what is the air that is left in the house? Cold air, so it becomes cooler a lot faster. Okay, the wall should be a material of low specific heat capacity. Okay, no, it should be high specific capacity. Yeah, sorry, this is a mistake. This should be high. Okay, high specific capacity, so that it becomes hotter slower. Yeah, if let's say your entire house is made of metal, and if you stay inside the house, wow, it'll be like an oven. Okay, so usually cement has a very high specific heat capacity, so it takes a longer time to become hotter. But of course, if you compare cement and wood, can we go back to that? Let's compare cement and wood. Wood is over here, concrete is over here. Now, tengok. So concrete has a low specific capacity compared to wood. Wood has a higher specific heat capacity. That means it takes a longer time for rumah papan to become hotter. Okay, which means if you stay in the rumah papan, kan, you are generally cooler than the people who stay in cement houses like me lah. Okay, because wood has a high specific capacity. It takes a long time to get hot, but the only problem is it takes a long time to get cool also lah. Okay, manakala concrete is the opposite. It takes a very fast time to get hot, but it's very fast to be cooler. Okay, so yes, sorry. Okay, one last one kalau di Sabah ni kan we call it a tumas. Yeah, so last time when I was teaching my students, they say, oh ini tumas, but ini tumas. But actually it's called a thermos flask lah. The purpose of the thermos flask is to keep hot water hotter for a longer time, or cold water cold for a longer time. Okay, but usually we use flasks for soups, for hot things. So we want the hot soup to remain hot for a long time. Okay, so this is what we do. We put a plastic stopper. The plastic stopper is to trap the heat inside lah. Okay, so the heat dia tidak sedang terbebas. Okay. Secondly, there is a vacuum over here. Okay, ada satu ruangan, ada satu lapisan di sini yang tiada udara. Okay, so that we prevent the heat loss through conduction or convection. Because kalau ada udara di sini, then haba itu boleh mengalir keluar. But because there's no heat, there's no air over here, it is a vacuum. Okay, so the heat loss will be prevented. Thirdly, we want to have this double walled tube, which is made of glass, okay, or something that is of high specific capacity. High specific capacity means it takes a longer time to cool down. Okay, and of course we coat it with a shiny paint. Like usually tumas kan di dalamnya is besi. Kita nampak macam besi lah. Okay, so that the heat will be reflected. Okay, and it will reduce the heat loss. If you have a tumas, if you have a thermos flask, okay, go and look at this lah. Okay, I have a thermos. It's not a flask, but it's what is it called? It's a thermos container lah. Okay, and you find that inside actually is metal, so that the heat will just reflect from one to another, and it will reduce the heat loss. Okay, but actually for me, the most important is this hollow plastic stopper lah. Okay, because the main way, cara yang paling utama yang haba boleh terlepas is from this hole over here. Okay, because remember, hot air goes out, and when hot air goes out, what comes in? Cold air. Okay, so this plastic stopper is actually, for me, it is the most important. Okay, and the invention of the thermos flask is amazing lah. You can keep soups. Kalau kau simpan soup di dalam bekas biasa, kan, usually 1-2 hours, it will become cold already. But in a thermos flask, it's not 1-2 hours, it's about 7 to 8 hours. Sometimes the whole day, sometimes 10 hours, and it is still, well, it is not as hot as it was before, but it is still hot enough untuk kamu menikmati soup yang sangat panas, soup yang panas. Okay, sometimes it can be a bit too hot lah, but yeah. Okay, so the invention of the thermos flask is actually very important. Okay, so actually that's it for today. In our class on Tuesday, we will talk more about the calculation. But for today, I want you to understand the concept of specific capacity, okay, and the applications of it, okay, which to me actually requires more lah. The next one, calculation is just calculation only lah, tidak banyak ini. But the understanding of specific heat capacity and what it means and the applications, okay, is actually very important. Okay, so if there's any part of this today's class that you're not very sure of, you can always watch the video which I will post on YouTube later lah. Okay, in case you want to repeat this lesson.